Hello and welcome everyone. My name is Sohail Shagasi. Before we start, let me ask you something. Do you know what makes a system truly successful? Well, in this lecture, we are going to uncover the answer by understanding the difference between two important concepts: the system development lifecycle, abbreviated as SDLC, and the software development lifecycle. These terms are often misunderstood and sometimes used interchangeably. Today, we are here to clear up any confusion and provide you with a solid understanding of each. So, let's get started. Now, let's go over the objectives that we will cover in this lecture. First, we will start by defining what each of these life cycles involves. Next, we will compare and contrast system development lifecycle and software development lifecycle to highlight their unique aspects. And following that, we will go over fundamental components of each lifecycle with practical examples to show these concepts. Finally, we will discuss the rules and deliverables associated with each life cycles to understand the responsibilities and outcomes expected at each stage of the SDLC. By covering these objectives, you will be equipped with a comprehensive understanding of both system and software development life cycles and be able to distinguish between them effectively. With these goals in mind, let's dive right into our first topic, the definitions of system and software development lifecycle. First of all, let's look at the system development lifecycle, commonly known as SDLC. The system development lifecycle involves the development of both hardware and software components. It is a structured approach used to plan, create, test, and deploy an information system. This lifecycle typically includes stages such as planning, analysis, design, development, integration and testing, implementation, and maintenance. As you can see in this diagram, each stage plays a critical role in ensuring the system meets the desired requirements and functions effectively. Now, let's look at an example to make this concept more concrete. In order to show the system development lifecycle in action, let's consider the production or manufacturing of wind turbines. In this example, both hardware and software components are crucial. The hardware includes the physical parts of the turbine, while the software might control the turbine's operations and monitor its performance. Here are some tools that system architects might use in the process, such as AutoCAD, SolidWorks, SketchUp, Fusion 360. These tools are used for architecture, engineering, and construction, indicating how various information systems, both hardware and software, are integrated into the system design process. By understanding this example, you can see how the system development lifecycle covers a wide range of activities and tools, confirming that the entire system, both hardware and software, works together seamlessly. Now that we have covered the system development lifecycle, let's move on to the software development lifecycle. The software development lifecycle is all about creating, and maintaining software applications, we can think of it as a branch of the broader system development lifecycle, sharing many of its features. It involves a sequence of steps designed to make sure we build top-notch software, starting from the initial planning phase and continuing all the way through to maintenance after the software is up and running. Moving on to an example for better understanding, let's imagine we are developing a mobile banking application. First, we start with planning, where we figure out what the app needs to do and what features it should have. Then we move on to analyzing how to achieve these goals, followed by designing the app's look and feel. Next comes the actual building or coding of the app. Once that's done, we test it thoroughly to make sure it works correctly. And after that, we launch the app for users to get the feedback from the stakeholders or end users. But it doesn't stop there. We continue to maintain and update the app to keep it secure and running smoothly. Now let's discuss the tools used in software development lifecycle. For example, IDEs or integrated development environments such as Visual Studio and IntelliJ IDEA help us write and manage code more efficiently. Next is version control systems such as Git and Subversion, which are crucial for tracking changes and collaborating with other developers. Next, project management tools like Jira and Trello help in planning and keeping track of the progress of software projects. Looking at testing tools such as Selenium and JUnit, which help us automate and manage the testing process. And finally, tools such as Azure DevOps, Jenkins, and Travis are used to automate the deployment pipelines, ensuring new code is integrated and deployed quickly and reliably. By using these tools, we can effectively manage the SDLC and pretty much create high-quality software applications. Now that we have talked about both system and the software development lifecycle, let's have a look at the main differences between them. To clarify the focus of each cycle, the system lifecycle primarily deals with integrating everything, including hardware, software, and network components, while the software lifecycle concentrates on how well software applications work, ensuring they meet user needs and perform correctly. Similarly, if we look at the scope, the system lifecycle covers both hardware and software, making sure the whole system works together smoothly. However, the software development lifecycle is all about developing and maintaining software applications. For instance, for the system development lifecycle, think about the Siemens producing wind turbines, which requires careful coordination between hardware and software. But for the software lifecycle, imagine creating an enterprise application focused on improving business processes through software development and maintenance. Understanding these differences is key to choosing the right approach for your project. Moving on to the roles and deliverables also known as outcomes, in each phase. Let's first look at the software development lifecycle. It's quite similar to the system development lifecycle, but focuses specifically on software. Here is how it breaks down. First, we have the requirements phase. The key players are the product manager, business analyst, and systems analyst. What we eventually get out of this phase are the requirements document, user stories, and use case diagrams. This phase is important. It defines exactly what the software needs to accomplish. Next is the design phase. Here, the software architect, solution architect, and UI/UX designers are involved. The deliverables include software design documents such as high-level design, low-level design, wireframes, mockups, and database schemas are also the outcomes of this phase. This phase is all about creating detailed designs that guide the development process. Then comes the development phase. Software developers and database administrators are the main roles here. Source code and database scripts are the outcome of this phase. During this phase, the actual coding and database creation happens, resulting in the first version of the software. After that, we move to the testing phase. Quality assurance engineers and automated testers take the lead. The outcomes are test plans, test cases, and bug reports. Testing is crucial for identifying and fixing defects, ensuring the software is reliable and functional. Next, we have the deployment phase. DevOps engineers and system administrators are involved. Deliverables such as deployed applications, deployment scripts, and configuration files are included. In this phase, the software is released into the production environment, which makes it available for end users. And finally, there is the maintenance phase. Maintenance engineers and customer support play key roles. We get bug fixes, updates, and performance reports. This phase ensures that the software stays updated, secure, and efficient, addressing any issues that come up after deployment. So, these phases, with their respective roles and outcomes, ensure that the software development process is thorough, efficient, and produces high-quality results. Next, let's briefly touch on the system SDLC. It's similar to the software SDLC, but has a broader focus. The system SDLC includes both hardware and software components and ensures the entire system works together seamlessly. For example, the system SDLC phases like planning, analysis, design, implementation, testing, deployment, and maintenance include not just software, but also the physical hardware and network infrastructure. Understanding these distinctions helps us apply the right lifecycle to our projects, ensuring everything runs smoothly, whether we are focusing on software alone or the entire system. Let's summarize what we have covered today. we explored the key phases and components of both the system and software development life cycles. Next, we clarified the scope and focus of each life cycle, highlighting the distinct areas they address. And finally, the roles involved and the critical deliverables produced at each stage of both life cycles. One thing I would like to emphasize that by mastering these concepts, you will be better equipped to manage projects successfully, guaranteeing both systems and software meet their intended goals. With that, thank you for your attention.